In society, we have seen technology has evolved over the past 30 years, from not having internet, the introduction of slow internet, to home broadband, having landline phones replaced by cell phones, flip phones, and evolving into smartphones that run all sorts of applications. There have been major technology impacts on the factory floor also. In this presentation, we're going to look at solving big problems using hardware and software to analyze data that has been collected from smart machines on the factory floor. So what is a smart machine? A smart machine is a machine that is connected and integrated, is real-time information enabled, safe and secure, and provides remote access. A smart machine produces real-time data. Some of that data can be analyzed to produce key performance indicators that can be used to improve production, while other data can be used for predictive and preventative maintenance and therefore reduce downtime. Why build smart machines? Key business drivers for OEMs. Simplified integration. For an OEM, they want to make sure everything integrates easily so it reduces their time to put the machine together. Program it, test it, and send it out to their customer. Information enabled, so the customer knows how to make decisions based on what is happening within the machine. Enhanced security. They want to make sure they have enhanced security so not to allow anyone to have access to the system. Predictive maintenance. Information can be provided for problems before the problems occur. This information can be used to guide preventative maintenance procedures. The adaptive machine. Make it easy for the customer to move from one product to another. New revenue streams. Potentially giving the OEM new revenue streams. These revenue streams can be services such as monitoring the machine for the customer or remotely helping them troubleshoot the system. Smart machines, KPI impact on end users. Revenue growth. Key performance indicators are useful information that can be used to reduce machine setup times, enabling the end user to produce more and in turn increasing revenue. Profitability. KPI information will allow them to make real-time decisions to make adjustments to their systems to increase production, therefore reducing the cost of goods, selling, and administrative costs. Working capital. With an increase in production, products will get to market faster and spend less days in inventory. As well, decrease the time for customer payments or days of sales outstanding and enable the manufacturer to pay its suppliers quicker or decrease days purchases outstanding. Asset utilization. Enable the end user to determine if they have the capacity in their existing systems to produce more variety, or do they need to purchase more assets to produce additional products? Rockwell Automation and PTC have announced that they have launched FactoryTalk Innovation Suite, powered by PTC, a software suite that enables companies to optimize their industrial operations and enhance productivity by providing decision makers with improved data and insights. The new suite delivers complete visibility of operations and system status from one source of information inside the organization. The collaborative offering is the first to integrate technologies from both companies following the strategic partnership announcement in June in 2018. FactoryTalk Innovation Suite improves connectivity to operational technology devices on the plant floor, natively supporting the rapid, scalable, and secure connection of most commonly used industrial equipment. Combined with data from information applications and systems, decision makers can now gain a complete digital representation of the industrial equipment, lines, and facilities from anywhere within the enterprise. Next is a demonstration of ThingWorx Enterprise software.
I'm going to show what an IoT application can look like. And, we're going to look at it from a couple different perspectives. One perspective, as an end user or maybe a corporate perspective, and then another one as a machine builder, implementing an IoT structure to understand better about what their customers are doing and also to provide a better customer experience. So what I've did is I just opened it up and I've connected to ThingWorx here, and we're looking at the overall corporate screen. We can look at where are all the different facilities, across the Americas and Europe and stuff like that. We could actually go down into maybe look at a specific facility. We'll take a look at the Cincinnati facility, for instance, and we're seeing location and we're seeing some, overall information about, what is the OEE going on at the facility, and this is for overall production, and then, how much scrap and stuff along those lines. So if we take a look at a specific plant, and we'd have maybe the plant dashboard, and once again we're seeing statistics, and this is maybe a little more detail about that particular facility, and I want to further go in and look at the KPIs or the key performance indicators, and see how they're trending, maybe for the current shift, or look over the whole day, or even the month. So get an idea of where are we moving. Are we improving? Are we having, are we struggling today? If we're struggling, we want to know immediately so that we can, we can hurry up and deal with it. The idea here is by closing the loop on what's going on, we can create that quicker response and actually, better overall productivity. So take a look at maybe an hourly roll up and, what type of production has been done today. Take a look at, particular lines and stuff like that, the consumption, the material utilizations and stuff like that. I could even export this out to a spreadsheet if I wanted to, and open that up. And in that case, if I was one of those folks that I would like to take a look at the raw data and build it around in my spreadsheet, I could always do that also. Maybe another look at the plant. We'll take a look at the genealogy, what products have been consumed for a particular unit. And I'm going to bring up here, and I'll see the fishbone representation of what all went into a particular unit produced. And this is also, forward and reverse. You can see what's gone in, and then what units have gone, what lot numbers have gone into what end product. Things like, specific line utilization, the charts of, what is going on. Take a look at, the production here. We have, these are, we can see, which work orders are moving on to schedule, and maybe which ones have some challenges. I could always, pick a different lot number to take a look at that. Maybe take a look at the details for a specific unit that's produced, and drill down and, actually, figure out what's going on in a particular, at a particular site, or, at a particular unit and stuff along those lines. Take a look at, the bill of materials that was used for the unit, for the, the consumptions, how the inventory is going. If I want to drill into, any particular units on that, I can also take a look at that. Once again, maybe I want to add some scrap. This particular unit was bad. I'll go ahead and select the particular failure mode, and what happened and stuff along those lines. Maybe look at some charting, and we're going to talk a little bit more about this in some later dashboards here, and then maybe get a view of the overall inventory, and even the particular workspaces, or how I can actually add in information about what's available, and the collaboration being if I wanted to add a comment in, or make a note, that's kind of like what I would call a digital logbook, so to speak. Now with our IoT platform, we can connect to multiple sources. So we're connecting, to our controllers, the PLCs and stuff like that. But we're also connecting to the ERP system, Enterprise Resource Planning System, and we have native connectors to systems like SAP. We also have all kinds of IT type connectors, RESTful interfaces, and message buses, and database connectivity, ODBC, and JDBC, and JSON, and communications to different types of cloud infrastructures. Azure IoT Hub, we can run on premise or in the hub, or both, and and share the same same data sources, or share that data source. So our IoT platform is very good for this cross collaboration. It's very good at bringing in data from disparate data sources, and 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 presenting it in a way that helps and makes sense. We can move over here, maybe take a look at the maintenance. Here's another example of creating a log, or I can even open up a chat session with one of the other maintenance professionals that are in the facility, see the different faults, and then organize that into a a histogram. Take a look at it. Look at a different way. How the idea is to look at it in a way that helps us understand and react to it. Here we're taking a look at an actual quality procedure, and it has step-by-step instructions on on how to make the measurement, and then record the measurement and keep track of the defects and what we have to do, stuff along those lines. So if we want to take a look at so that's the actual manufacturing. Maybe we want to get a feel for how our tractors are running out in the field. And so we have the ability, for instance, to put one of our controllers, one of our edge devices on a particular production unit, in this case a tractor, but it could be an OEM machine, any type of skid. It could be, we put them on trucks and trains and, all kinds of devices and stuff like that over the years. Here's an example of, I can see that one of my particular tractors is having, I can select a different one and see where they want. If I want to take a look at maybe the overview of that particular equipment, how is it running, maybe see details of that particular unit. In this case, I'm actually going to bring up, take a look at this particular tractor right here, and I can see, the status of, as a change in state. In this case, we can see that the hydraulic pressure has dropped below a critical low, which has created an automatic alert to us to dispatch maintenance and to actually handle that. And also take a look at, other things that have to do along with the actual, operations, and even see the route of that it's working in a particular field in this case. We'll probably send out a service order. We'll probably take a look at some diagnostics and the threshold where the issues are. Of course, the message logs and the fault logs. So the idea here is we have a complete, comprehensive feel for, what is going on with our equipment, but also we have the ability to, make this available to our customers. So we can, these is a way that you can actually enhance your customer's experience, and often actually for an OEM create an additional, value add and an additional service that these can then provide these dashboards as a subscription. And we're seeing a lot of OEM machine builders do that. They are, in the past, they sent out a machine and maybe they would send out a technician on a monthly basis to to check it out and stuff like this. But by creating this kind of an infrastructure, now they can dispatch somebody immediately if there's problems, or if they're running, if it's running low on a particular material, they can dispatch somebody. So it's a very much a way of improving the uptime and the capabilities for the different remote equipment that you have out there. So we can see some different examples. Here's an example of coffee machines out in the facility, and this is using some machine learning. So machine learning is where we use some very advanced algorithms, understand how equipment should work, and then if something starts to become anomalous, or we see a deterioration in some of those parameters, we can then alert on that. We can say, hey, this machine is actually operating differently than it normally does. And this is different than something like a high limit or a low limit. Those are pretty straightforward. You set a, hey, the temperature must be below this. But what this is much more sensitive in that it actually learns the characteristics of the machine and how the machine is being used. And then it is actually triggering off of changes in that. And right here, I can see that one of the pieces of equipment appears to be, I'm going to take a look at that particular unit, where I can see the risk is very high, contributing factors, when give me an idea of, what I need to actually take a look at for that. In this case, when we're driving in machine failure for the grinder, it's giving the histogram, the history, the air log occurrence for that piece of equipment. In this case, I can see that I'm having some heating element failures, and also some potential, keep track of the pump, in kind of issues along those lines. When we get into the predictive model here, it's giving me an actual analysis of, what's normal, and then, what could be an issue. And then we get into the actual machine scoring, where we're, constantly evaluating the particular model. So another form we take a look at, another way of looking at this, maybe not so much at the system level, but down at the individual unit. In this case, we're taking a look at some pumps, and I want to take a look maybe at the details of pump number A. And here I'm seeing how the vibration and the pump jacket, and this is somewhat simulated data, so it's maybe not quite how you would normally see it, if it was actually connected up to a pump. But the concept of how we're taking a look at it is the same. And this way we can actually see that we have a predictive, discharge fault. So I'm going to take a look at the streaming analytics, the information that's coming in. It's doing some standard deviations. Built in, we can put in a traditional, SBC type chart, or even a predictive model that in this case is showing, what is normal. This is what we would call a classification model. And then, or a temporal classification. And then, if something is actually working out of spec, we can then see how that's impacted here. Let's see if I pick a different pump here. We can pull my pumps over here. Maybe take another look at a different pump. I wanted to show that SVC chart, and it didn't seem to have an SVC chart for pump A. Maybe pump B. Yeah, pump B has one here, and we can actually see, in this case, the X bar chart, and then the range chart also that goes along with this, and it'll calculate the the capabilities and all that kind of good stuff. So with that, go ahead and we have a number of different types of demos and different types of industry and scenarios, and even some pre-built applications. So if you see something that you think would be applicable in your particular operations, let us know, and we can definitely schedule up a follow-up and maybe go into this in more detail. And I'm going to talk more about what's behind the scenes and how you would implement this infrastructure after the break.
Okay, digital transformation reference architecture. This is an overview of how to collect data from the equipment on the factory floor, then send it to the enterprising level. Level 01. The network-ready machine is connected, and you can see information from it. Connected workers, which allows you to bring in things such as augmented reality and virtual reality. IIoT sensors, connected lab equipment, and you can even bring in information about tools. Level 2. Information can be brought in by using a SCADA or HMI, looking at DCS or engineering tools, or asset management. Level 3 is tying business systems into machines. Software such as MES, MOM, OEE quality. Historian is logging information for what is happening within the systems. Batch process control, which is used to determine what items are added and when and what quantities, how long things need to be mixed for, etc. Then there is SPS and LIMS portion. Level 4 is the ERP scheduling system, knowing what you have for the raw products that are coming in and what you need for the products. What are your orders coming in? How much you need to produce the product? The CAD, PLM, PDM portion, there might be HR finance depending on what your requirement for operators for running the system, maintenance people for maintaining the system. There is the enterprise historian taking information from various production lines, plants, and sending the information to the enterprise system so they can see their actual production. See what the available capacity is. If there are new orders, they can use this information to select what plant they have the capacity to produce this product. Digital transformation platforms. This could be the data store. It could be the analytics taking a look at what is happening in the current system, giving feedback on what you're currently seeing. It could be the connection from the plant floor up to the corporate level. Augmented reality, virtual reality, and machine learning. The IIoT, analytics, data store, conductivity, gateway, making sure you have the information coming from the machine to the corporate level. Augmented reality or virtual reality for training new people on new systems for new processes. Artificial intelligence or digital twin, giving you the capability to better understand how the system is working. Then enable the decisions of adjusting things to potentially be done by an artificial intelligent device. Looking at a modeling portion, making adjustments accordingly to the model so the adjustments are within its parameters. Looking at the layout of the system using a digital twin to determine what is the capability or finding what potential roadblocks that are within the system. See if you can increase the speed, increase the capacity of the system. Taking all the information you are getting from your systems, then putting it into dashboards, which makes it easier to make decisions based on content opposed to information in data tables. This is done by utilizing Microsoft operating systems, Rockwell products, and PTC products. There is a wide range regarding the analytics. There are some basic analytics as well as advanced and autonomous factories. The descriptive historical data indicating what happened does not give any advance notice. This says what is current from the situation of the machine. In this case, we have a motor fault. You can step up to the next portion and have some diagnostics on why is it faulted. In this case, we have a motor fault because it has high current. Now, if we had some predictive capability, we might have some notifications ahead of time before we actually get that fault. That would tell us that if we continue running this way, we're going to have a fault. If you have a prescriptive portion of the analytics in place, not only can you say that you could potentially have a fault, but you could also provide a solution that may eliminate that fault from actually occurring. In this case, a motor has high current. Therefore, the motor will fault if no preventative action is taken. Decreasing the actual load on the motor will prevent the fault. The last point is the artificial intelligence control action, which will do the analysis and the adjustments and have no human interaction to make those changes. Analytics value chain evolution. This graph shows the progress of analytics capabilities. Standard reports. For your very basic needs, you have standard reports which tells you what has happened, not why. How is my shift running? How many parts were produced? How many parts are good parts? How many are defective? Ad hoc reports drill down. Will give not just report events such as an e-stop was pressed or the line was starved for parts. The reports will give the number of times the events have occurred. So how many times was the e-stop pressed? How many times was the line starved for parts? And when did the event occur? This will enable personnel to make better decisions. Alerts. The additional information from ad hoc reports can be sent to the stakeholders. This will notify the stakeholders of recurring problems such as numerous e-stops, the production line being starved for parts, which would enable them to prioritize problems. Statistical analysis. The information now can be analyzed to find out why this is happening. Is it a training problem? Is part of a machine not functioning properly and requires repair? Or is it a machine design problem? Is the machine properly cleaned and maintained for production? Forecasting. The information from statistical analysis is used to predict how the problems will impact production, how much production will drop, or scrap parts will increase. Predictive analytics. Analyzing this information and being able to see what the problems are occurring more frequently will be an indication to predict what failures will occur. Being able to predict failures before they occur will give the ability to plan preventative maintenance. Optimization. When you have forecasting and predictive analytics, you can take corrective action. If the problem is training, you can plan what necessary training is needed. If the production line needs upgrading, or your planned future projects. Industry and technology alignment. PTC and Rockwell coming together to offer the best in class from both sides to our customers. For perfectly aligned focus, Rockwell Automation brings connected enterprise and operations. PTC brings smart connected operations. Complementary expertise. Rockwell has branded recognition, domain expertise. PTC has tech expertise. Complementary segments. The Rockwell segments are materials, oil and gas, pharma and chemical, mining, and consumer packaged goods. PTC segments are industrial, retail, medical devices, aerospace and defense, and electronic and high tech. Overlapping segments are automotive and machine builder. Complementary products. For Rockwell Automation, Allen Bradley brings industrial sensors and networking and automation. FactoryTalk brings analytics, industrial specific MES. PTC, Kepware brings conductivity. ThingWorx brings IoT. Vuforia is augmented reality. Windchill is PLM, product lifecycle management, and Creo is computer-aided design. Predictive analytics process. Let's look at a process that we would go through when looking at predictive analytics for a system. The slide diagram represents the LogixAI process that we would go through. It can also represent a higher level of analytics. We first need to understand what is the problem we are trying to solve. The customer might be impressed with the technology, but if they don't know how to apply it to their application and what process they need to go through, it will be a failure on applying it. So step 1, define business problem. We need to clearly define the business problem. Set what is the successful criteria. Define clear data science objectives. Map to machine learning problem. Break business problems into data science problems. Identify machine learning problem categories. Data preparation. Understand the data. This is one of the biggest challenges, determining which inputs, what constraints in the system, what data affects how the system runs. Then perform the required transformation. Exploratory data analysis. Perform statistical and visual analysis. Discover and handle outliers, errors. There will be some stuff that will not be your typical model. Shortlist predictive modeling techniques. This will take about 80% of the time for your system. If this is not done well up front, the other 20% will give you information, but not the right information nor the right responses to what is happening. So if you don't do the upfront accurately, the black flowchart boxes, then the back part, the green flowchart boxes, will not give you what you need. Modeling. Once you have all the information, you do some actual learning with it. Then you will get a model from that. You will repeat the learning a few times to ensure you are getting something consistent. Now what happens if you can't get the model based on the information? You go back to the beginning, define business problem, black box, and start over. Review each of the steps and information that was previously used. Once you have the new modeling, you are going to do the evaluation. Evaluation is to check if this is now giving proper information and giving good guidance. Operationalize. Once this is in place, then you will put it into your system and have it monitor how your system is running. If the system is out of those typical settings, it will adjust according to the modeling that has been put in place. Okay, next is use case production and performance monitoring. Understand the performance of physical assets and digital systems through one consolidated source of information, enterprise data visibility and plant benchmarking, and real-time quality KPIs. Production and performance monitoring connect users and information, such as data presented in context from disparate systems, no need to switch between different environments, visibility extended to assets inside and outside the plant, wraps and extends existing user interfaces and technologies such as embedded HMI content, analytics and results, benchmarks across operational assets, workforce instructions and work plans. Also, single workforce sign-on. Thin Manager can then distribute ThingWorx and other visuals such as live video, non-integrated applications, enterprise tools, and many more. Next use case is predictive and prescriptive maintenance. Anticipate and resolve issues before they happen. Robust digital representation of your assets combined with big data capabilities allows applications to become more predictive. Automated machine learning. Here's how ThingWorx Analytics Server uses advanced artificial intelligence and machine learning to create, operationalize, and maintain advanced intelligence from IoT data. When the ML technology is connected to the Thing model or data is uploaded, the data set is broken into two different portions. The first is a training set of data, normally 80% of the set, and the second is a validation set of data, which is 20% of the data set. The ML technology then begins to learn about the outcome that you flag within the data set. This is what is known as the supervised machine learning approach. As the technology begins to learn about the subject, thousands of predictive and/or simulative models are created in parallel and are constantly checked against the validation set of data that was held back from the original data set. Essentially, the AI technology tries to predict the data that already occurred, weighed properly to test the validity of the model. Once an optimal model is identified, it is then optimized. The model that performed the best against the validation set of data is then ready for production. It's accessible via REST APIs or via ThingWorx. ThingWorx Analytics Server is not a black box. It tells a user how the model was created, what the scores were against the validation set of data, and finally the error rates of the models it created. This gives insight into the performance of the AI machine learning technology itself and not the output data. This is important for developers, data scientists, and business analysts who may use the platform. Use case digital worker. The game is productivity, but the winner is a happy employee. Digital work instructions replacing paper or PDF based, knowledge sharing and collaboration, machine setup and changeover instructions. Digital worker modernized service and work order instructions for workforce productivity. This helps increase the productivity of the operator and maintenance personnel by making it easier to learn the processes. The digital formats that are used to present procedural processes to the digital worker are augmented reality and virtual reality. A training expert will record a step-by-step procedure, for example, a production line changeover procedure in augmented reality or virtual reality. The digital worker then can view the procedure using a virtual reality headset. Having the ability to watch the training procedure while performing the procedure makes it easier for the operator because it is less likely they'll miss a step. Also, they don't have to memorize the procedures. Next, we'll watch a Vuforia Expert Capture demo.
Vuforia Expert Capture is a new workforce productivity solution from PTC, which captures the tacit knowledge of frontline experts in situ, where and when they do their work, and then makes it available to any worker to effectively and efficiently perform that same procedure. Using the Vuforia Capture app on a head-worn device, the subject matter expert can record their work procedures step by step, in real time. No tedious written documentation work is required. By using intuitive voice or gesture commands,
Next step. Ensure voltage selector is on 120 volts.
the user can control the recording of the video, take photos, and mark important moments to edit later, all hands-free while they work. The captured knowledge can then be revised and configured in Vuforia's web procedure editor before publishing. Once published, captured instructions are consumed via Vuforia View on a HoloLens, RealWear, or mobile device. This gives a clear and immersive first-person perspective of what to do and how to do it best. PTC's Vuforia Expert Capture solution saves your company time and money associated with the creation of traditional training and documentation methods, which ultimately results in significant downstream benefits in areas like quality, safety, and overall workforce productivity.
This is a demo using Vuforia Augmented Reality. This is a visual recording of a step-by-step procedure for changing a valve. The operator is not looking in a virtual reality headset, but rather using their cell phone. This is a 4-step procedure. And the first step is to identify the part that needs to be replaced. Next is analyze the part. Step 3 is replace the part. Close the first valve, close the second valve, and then remove the bolts and remove the valve. And step 4 is verify the part number. Analytics value segmentation. This slide shows the difference between basic and advanced analytics and the impact they have at the device level, the system level, and enterprise level of a manufacturing facility. Basic analytics gives you descriptive and diagnostic analytics. So at the device level, you have, am I running okay? Or, why did a fault happen? At the system level, is line 1 running okay? Or why is line 1 quality poor? At the enterprise level, which facility performed the best? Why is Site A throughput behind plan? Then advanced analytics gives you predictive and prescriptive analytics. So at the device level, I predict a fault will happen soon, then what action should be taken to avoid the fault? Then at the system level, I predict that line 1 quality is moving out of tolerance. What action should the operator take to avoid poor quality? Then at the enterprise level, I predict that Site A will be behind plan soon. What action should I take to avoid Site A from falling behind plan? Looking at a use case with some data. What can I do with it? Analysis and insight. Sensor validation, predictive KPIs, anomaly detection, predictive maintenance, target optimization, dynamic optimization, and machine learning. This is taking the information from a system on how it is running under ideal conditions and when there are problems. Analyzing the information and being able to detect problems, then giving some guidance on what should be done. For example, for a hydroform press, if a new batch of steel tubes are loaded into the system, the pressure settings might have to be adjusted because the new steel tubes are slightly harder. Depending on how you set the system up, adjustments can be done automatically, or the information can be sent to an operator and they would make the adjustments. But when an operator has to make the adjustments manually, this is a whole process to go through. Machine Process Cell Predictive Analytics. Streaming automated machine learning, adaptive online learning in the chassis connected with the target controller. Automated machine learning modeling for ControlLogix tags. Learn what's normal, find deviations from normal, and estimate values from incomplete data. It's a FactoryTalk Analytics LogixAI module. The first step is determining what you think the problem is. Identify what key elements in the process control or affect the running of the process, then do some learning on data. Learning data should only be done while the system is running optimally and without problems. Then creating a model based on optimal data, which will serve as a standard model for the process to run. Prove the model, then put it into production so it can make adjustments to the process based on the proven model. FactoryTalk Analytics LogixAI module has 2 modes of operation. The first is virtual sensor, which estimates values from incomplete data. And the second is anomaly detection, learn what's normal and find deviations from normal. The virtual sensor quality assurance example estimate manual measurements. Quality parameters like final humidity within packaged products can correlate to longer shelf life and higher customer satisfaction. To measure actual values on a finished product, manufacturers rely upon performing manual measurements that destroy otherwise sellable products. Embedded machine learning intelligence of the FactoryTalk Analytics LogixAI add-on module into the control chassis gives the ability to model a virtual sensor. It uses the relevant data to estimate the quality parameter without manual recording. The anomaly detection for a condition monitoring example, blade dulling. In many manufacturing industries, blades are used for cutting operations. If a motor is used to turn the blade and a VFD is used to control the motor, the torque parameter of the VFD can be used to indicate when the blade starts to dull. Then, the proactive alert can be used to schedule downtime to replace the blade. FactoryTalk Analytics Edge. The power of Edge is it's a small piece of software that can run on a variety of form factors, including a module on our ControlLogix platform. In the future, it'll be able to run machine learning algorithms. It can do some compute, store, forward, and make some decisions that typically cannot be done in a controller. PMML Model on Edge Pipeline. PMML stands for Predictive Model Markup Language. It is the de facto standard to represent predictive solutions, or it's like an exchange format for models. Support PMML models version 4.3 on Edge pipelines. Allow users to operationalize models built on ThingWorx, exported into PMML format, and imported into Edge pipelines. Support the following types of models: regression, logistic regression, cluster model, naive Bayes, associated rules, support vector machine, and neuronet. Edge deployments, high-level data flow. Along the bottom of the slide shows the devices that can run FactoryTalk Edge Analytics. For machine and equipment, there's a ControlLogix PLC with a compute module. For line and equipment group, there's an appliance, probably a thin client. And for plant area, there's a server. All these devices are having their data sent up either to a cloud service or an on-premise database. In the upper middle of the slide, there's Edge Advanced Services, which shows pipeline management and development. This is where you can create your data models, convert them to PMML format, and then download them to all the different Edge devices. FactoryTalk Edge Gateway, driving industry connectivity. Creates connections for smart devices to collect data. The data then is contextualized so it has meaning and is not just data in a database. Then the contextualized data can be mapped out. Smart objects. Information models built using smart objects. Creates additional context by packaging the data collection within an overall timestamp. The AOI defines how to collect the smart object data, either on scan, triggered, or on change. Hierarchical data collection allows for synchronous data collection at higher speeds than capable otherwise. Smart objects differentiation. Information model built using smart objects synchronizes with FactoryTalk Edge Gateway. Taking in raw information and putting it into a format that makes sense, then providing the information out with context. The FactoryTalk Edge Gateway can be incorporated with smart objects to contextualize building the information models. Configuring and applying configuration properties in the connection portion is bringing the data in from those models and then mapping it out. FactoryTalk Edge Gateway. Data sources are smart objects, Ethernet IP devices such as PLCs, drives, FactoryTalk Live Data, OPC DA for third-party connectivity to KEP server. The FactoryTalk Edge Gateway ingress or takes data into the data model, then the data is then mapped out and then stored and forwarded, and then egressed or sent out to data destinations such as ThingWorx, SQL Server databases, and Azure IoT Hub. The FactoryTalk Edge Gateway runs on Windows 10 Professional 64-bit, Windows Enterprise 64-bit, Windows IoT Enterprise 2016, Windows Server 2012 R2 Standard, Windows Server 2016 Standard, and Windows Server 2019 Standard. Infrastructure. FactoryTalk Edge Gateway. Reference architecture. Has various network devices. such as network-ready machine, networked machines, connected worker, other IIoT sensors, vision systems, connected lab equipment, tools and IIoT sensors. All that information coming into FactoryTalk Gateway having been processed by the analytics model, then sending the information to ThingWorx to have it put into a format that makes contextual sense. The information can also be sent to a SQL database and then forwarded on to ThingWorx. The SQL portion is not required for ThingWorx connectivity. ThingWorx is a platform that enables data connectivity, live data, transactional and time series, computation, perform calculations on the data, analytics, leveraging the analytics engine, for example, prediction, unified production model development, organized to meet customer needs, visualization, data shared and fused from different data sources and contexts, configure and extend via APIs and configurations. ThingWorx integrates with Vuforia for augmented reality, Windchill to surface data from PLM. Okay, this is a display created with ThingWorx. It shows integrated information from external sources, track production and inventories, benchmark different production sites and customers, contextualize and display KPIs, OEE, downtime, energy, and water. Create powerful mashups with any relevant information for the business. Information could be coming from different systems, making it difficult to find relative information for a process. By taking all the relative information, even if it is coming from different systems, and consolidating it all in one pane of glass, making it easier to make decisions by being able to see all the information in one place. Okay, ThingWorx has applications and accelerators. For example, Operator Advisor. This is role-based, read-write applications enabled by real-time IT/OT connectivity and augmented reality to improve operator quality and productivity. Controls Advisor. Remotely monitor and troubleshoot machine connectivity. Asset Advisor. Remotely monitor physical assets in real-time, automatically detect anomalies, and trigger alerts to improve efficiency and quality. Production Advisor. Real-time visibility and insight into production line performance and status. Okay, this slide shows Vuforia's software offerings. The Vuforia engine for developers gives the capability to actually see the contents and put it into real-world type of environment through virtual layering over top of it in virtual mode. Vuforia Studio gives the capability to create the visual steps on how to do something. If you have a process that you need to do, maybe it is to set up equipment, or maybe changing over from one product to another, augmented reality content can be created to show steps for that process. If you are changing parts out, part placement is shown, and any equipment or tools that are required are shown. Vuforia Chalk. For remote assistance, that allows both the expert and the person at the location to both see the same thing on each other's screens. Have a conversation, provide annotation so they can indicate what they are looking at to the other person. The expert can confirm what the other person needs to do and actually annotate it on the screen so the other person knows exactly what the expert is looking at and what the expert is asking them to do. FactoryTalk Innovation Suite powered by PTC. FactoryTalk Innovation Suite offers a great platform to quickly and easily represent an asset or production equipment in a digital representation so you can quickly connect all of the data that is important about an asset or a line and begin to immediately monitor the performance as well as predict the performance of that equipment. Achieving your digital transformation. Step 1, assess and plan. Step 2, secure and upgrade. Step 3, manage data and operations. Step 4, analyze and optimize. Smart manufacturing is the gateway to digital transformation. Connected smart devices open new windows of visibility into processes. Seamless connectivity spurs new collaboration. The connected enterprise converges plant-level and enterprise networks and securely connects people, processes, and technologies. This is a journey. We have consulting services to help you along the way. Electric Vehicle and Software Innovation Center in downtown San Jose, California, helping you accelerate discrete production with smart, flexible, and connected operations. Learn about digital technologies and standards to launch faster with less risk and cost. Test and develop new conceptual ideas in the customer test lab. Explore new strategies to create connected operations. Access virtually from anywhere in the world, coming soon. Greenfield Plant Launch Partnership. Planning. Consulting, process design, supply engagement, MES design. For design, there's specification development, automation libraries, production engineering. Integration, there's line integration, network validation, startup engineering. For launch, there's maintenance engineering, production reporting, OEE, KPIs. For optimization, there's predictive maintenance, production analytics, and production acceleration. All of this, from the planning to the optimization, is all looked at as you go through the whole system. You're trying to take all of the information into context. If you're looking at some of the information coming in, for example, what do you have installed for networks? If you're looking at what the data you need, where does it have to come from? Where does it have to be brought into? Then how do you contextualize it? Having to decide how you actually provide that information into a format that can be utilized for operations. Experience Industry 4. Live manufacturing demonstrations that show how to launch faster and maximize production using smart, flexible technology. And hands-on trials of the latest digital technology improves worker efficiency and decision-making in virtualized environments. Also, collaborate with industry experts, which show how to develop innovative EV and battery production architectures in our modern workspace. What is in the center? Meet full solutions for the EV powertrain and battery manufacturing with Rockwell Automation. In the center, there are some examples of actual virtual experiences. You can interact with the equipment. In the bottom right corner shows someone following a setup procedure using a tablet with augmented reality. Top right corner, people are experiencing virtual reality with a HoloLens headset. Realize your digital factory. From EV startups to mature automakers, we can help at any point in your journey. Rockwell Automation solutions are FactoryTalk Innovation Suite powered by PTC, Industrial Data Center, FactoryTalk Production Center, High Performance Hardware Wall, Zero Cabinet On-Machine Product Portfolio, and Emulate Digital Twin Software. Partner offerings are PTC Augmented Reality and Virtual Reality, Eagle Technologies with Battery Pack Demo, Harada Drive Assembly Demo, Microsoft IoT Technology, and Fanuc Robotics. PTC Augmented Reality Experience. For operator training, there's X-ray vision, contextualized guidance, and animations. For IIoT dashboards for critical information, there's machine safety status and order of operations. Emulate 3D is a software program used by engineers to create digital twin models of equipment that they are designing. They use these digital twin models to test their designs before building the equipment. Operators can be trained using virtual reality in conjunction with these digital twin models. The following is an example of a system created by Rockwell Automation. It consists of an 86-inch wall-mounted display, virtual reality headsets, a digital twin of a machine, engineering simulation. Looking through the virtual reality headset, you would see a digital twin of the machine within the Emulate 3D environment, being able to interact with it and run it. The processor in the loop simulation and operator training. The engineer can test their code with the digital twin in the virtual environment before the machine's controls are installed and wired, or even before the actual machine is built. Since this testing can be done ahead of the actual commissioning time can be greatly reduced. Once the engineer has finished testing the code, the digital twin can be used to train operators on how to run the machine in a virtual environment. This has the advantage of training the operators in advance and in a safer environment, but also will give them time to make changes to the controls based on the operator's feedback once approved by the engineer. Next is a demonstration of a Vuforia augmented reality experience at the EV Center of Excellence. To schedule a tour, virtual for now, contact your account manager, provide a list of what you want to see and experience, propose some dates for your tour visit at least 4 weeks in advance, and the Rockwell team will confirm. To wrap up, consulting on smart machine manufacturing, projects can be kept on schedule and on budget more accurately during the manufacturing commissioning phases by using digital tools and best practices. Thank you very much for attending this webinar.